In this video, we're going to look at algebraic division. We've seen in the past that we can simplify algebraic fractions by cancelling common factors. So an example might be 8x squared y over 4xy squared. We could look to cancel the 8 with the 4, the x squared with the x, and the y with the y squared. So we'd end up now with 2x over y. We could extend this to polynomials. A polynomial is simply a sum of variables raised to different positive powers. So an example of a polynomial might be a quadratic expression. So let's take a quadratic expression, x squared minus x minus 6, and we might want to divide this by x multiplied by x plus 2. To simplify this fraction, we would look to factor the numerator to x minus 3, and then we'd have x plus 2, and we'd look now to divide this by x and then x plus 2. So we can see the x plus 2's are common factors, they will cancel off, and we're left now with this simplified fraction of x minus 3 over x. In this video, we're going to look at dealing with improper fractions. An improper fraction is when the degree of the numerator is at least that of the denominator. The degree of the polynomial is the highest power now, in this case, x is taken to. So we can see that this now is a second degree polynomial. So if we had a cubic, it would be a third degree. If we had a quartic, a fourth degree. Now we can see this is an improper fraction. If I expanded the brackets, I've got x squared and x squared. Another example now of an improper fraction might be x to the fourth plus 2x plus 1 divided now by x cubed plus 3x minus 6. X to the fourth, x to the third, so we can see the degree of the numerator is at least that of the denominator, it's higher. Another example might be x cubed minus x plus 4 divided by x cubed plus 6x minus 3. What we've got here now is the degree of 3 and the degree of 3, it's an improper fraction. So what we're going to do is look at a range of techniques that we can use to now divide these two fractions. One of them is polynomial long division or algebraic division, and the other is equating coefficients. Okay, let's look at another one, and let's take x plus 1 now, and then we put this over, for example, x plus 2. This is now another improper fraction. We can see now that we got x to the first, and then we've got x to the first. Okay, let's move on and start some work with these. And to begin with, I'm going to take an example similar to the one that I've just looked at. Let's say we had now x plus 4 over now x plus 3. When we carry out polynomial long division or algebraic long division, it can often be quite time consuming. We can use a little trick for an example like this and rewrite the numerator as x plus 3 plus 1 over now the denominator of x plus 3. We can see this as a sum now of single fractions, and we could have x plus 3 over x plus 3, and then we could have now plus 1 over x plus 3. Clearly, x plus 3 over x plus 3 is going to give us 1, and then we're going to have 1 over x plus 3. We call this now the remainder, and we call this the quotient. Later on, we will define those terms. So we say that this is the quotient and this is the remainder. Often, the easiest way to see this is to take a numeric example. So let's say we had now 43 and we wanted to divide 43 by 7. Now I know that 42 divides by 7. 43 divided by 7 is going to give me now, and we could write this as 6 remainder 1, or we could now write this as 6 and 1/7. So these are two different ways that we could write it. Now if we look at this, we've got 43, and that's going to be equal to 7 times by 6, and then we're going to have plus 1. We call this now the dividend. Okay, this is a dividend. So what we're dividing now is the 43, and this is the dividend. So writing this here, dividend. This now is what we call the divisor. So this is the divisor. This now is going to be what we call the quotient. So in this case, we saw that the quotient was 1. This is now the quotient. And this is now, the 1 is what we call the remainder. Now, if we have a remainder of 0, we can see now that whatever we were dividing by was a factor. In our later work, we will see the consequences of that and how we can use that to solve problems. So for example, now if I had 42 and I divided it now by 7, 42 is going to be 7 times by 6. So our dividend is 42. That is now what we've got in the numerator. Our divisor is what we've got in the denominator. The quotient is what we're going to end up having left, i.e. that's how many times now 7 goes into 43 or 42, and then we're going to have a remainder, and we can see that that remainder here is going to be 0. Okay, so let's actually put this into action with some polynomial long division. So what I'm going to do is take a polynomial, and we're going to have now, let's say we've got x to the power, let's go for x to the power of 3, and then we'll have plus 4x squared minus 9x and then minus 36, and we're going to divide this by a linear factor now of x plus 3. So I've got a linear and then I've got a cubic. We can see this in improper fraction as we've got now x to the third over now x to the first. What we do is set up now the division, and you might have done something similar if you did now numeric long division when you were at primary school, or you might have done now long division with this particular example. What we do on the outside is have the x plus 3. So we say that this now is the divisor. So this is the divisor. We have now inside, under this bar right here, the dividend, and that's going to be now x cubed plus 4x squared minus 9x minus 36. So what we've got now, and I'll just put this up, this is going to now be the divisor, this is the dividend. What we end up with on top is the quotient, and then what we end up with down the bottom is what we call the remainder. And I'll label these up as we go. Now when we're working with a polynomial, say we had the x squared term missing, it's general convention that we would put 0x squared to ensure that our working is kept in order. So let's go ahead now and try and divide x cubed plus 4x squared minus 9x minus 36 by x plus 3. The first thing I say to myself now, does x go into x cubed? And the answer is it does. It goes in x squared times. Or if you like, what is x cubed divided by x? The answer is x squared. So straight off I put x squared above now this bar. This is going to form my quotient. At this stage I now multiply down. So I end up now with x cubed. I multiply down and I end up with 3x squared. At this stage I subtract downwards. We should always cancel these terms out. So that's going to leave me 0, and then I subtract downwards, that's going to leave me x squared. At this stage, I bring down the minus 9x. And the next question I ask myself is, does x go into positive or plus x squared? The answer is yes. Or, alternatively, what is x squared divided by x? The answer is now x. So, at this stage, I write, as part of my quotient, x. I multiply back down, which is going to give me x squared, and then I multiply down. That's going to give me plus now 3x. At this stage, I subtract downwards. Again, we get 0, and we're going to have now minus 12x. At this stage, I bring the minus 36 down, and we ask ourselves now, does x go into minus 12x, or what is minus 12x divided by x? The answer now is minus 12, and then we multiply down. So we end up with minus 12x minus 36. When we subtract away, we get 0 plus 0. This now is our remainder. So we have a remainder of 0, which tells me now that x plus 3 is a factor of this cubic. So if we wanted to go ahead and solve it, x minus 3 would be a solution if we set this to 0. And again, we will look at that later. So what we now have is this here. This is the quotient. So we end up with the quotient. We've got now the divisor. So the divisor, let's put that there. That's the divisor. We've got the dividend underneath here. The two things that you must know when you're working with this dividend are the quotient and remainder. So what we could do now is the following. We've got a remainder of 0. So we could express now x cubed plus 4x squared minus 9x minus 36 as the product of a linear factor of x plus 3 by now the quadratic factor of x squared. So we've got x squared plus x minus 12. Now, if we look at this quadratic, we can factor that further. So we've got x plus 3, and then we're going to have now x plus 4, and then x minus 3. So we can express this now as a product of 3 linear factors. So if we wanted, we could write now that when we write this out, we could say now that it's going to be the product of 3 linear factors without a remainder. So x plus 3 is now a linear factor, or we can say that this is exactly divisible by x plus 3. Okay, let's look at another example of an improper fraction. So this time, let's say we want to divide, and I'll take another cubic. It's not always going to be a cubic, but we might have, well, we may as well do some cubic ones. Let's do 5x squared minus 6x. Let's go for minus 2, and we will divide this now by a linear factor. Let's say we divide this by a linear factor now of x plus 1. So let's go ahead and set this up. So we've got now the divisor and the dividend. Those two pieces, or those two words, are not hugely important to remember in comparison to quotient and remainder. So we're going to have now x plus 1, and then we're going to be going into x cubed plus 5x squared minus 6x minus 2. And the first thing I'm asking myself is, do I need to put in any 0 x's or 0 x squared? X cubed, x squared, x, no x. Or if you like, x to the third, x to the second, x to the first, x to the 0. So we don't need to put any in. So let's go ahead now and look to divide this polynomial by the linear factor of x plus 1. So my first question is, does x go into x cubed? Or what is x cubed divided by x? Again, we get x squared. So we multiply down, we get x cubed. We multiply down, we get plus x squared. I now subtract away 0 plus 4x squared. I now bring the minus 6x down, and I say to myself, does x go into 4x squared? Yes, it does. It goes in plus 4x times. Or if you like, what is 4x squared divided by x? Multiplying down, we're going to get 4x squared, and then we're going to get plus 4x. So at this stage, I need to subtract downwards. That'll give me 0. This is now going to give me minus 10x. I then need to bring down the minus 2. So x is into minus 10x is going to go minus 10 times. Or what is minus 10x divided by x? Multiplying down minus 10x, and then we're going to have now minus 10. I subtract away, and I'm going to get 0, and then I'm going to get plus 8. So this time we don't have 0 plus 0, so we have a remainder now of 8. So what we could do is write this as follows. We could write this as x squared plus 4x minus 10. That is our quotient, and then we would say plus 8 over x plus 1, and that now is remainder. Now if we go back to the 43 and 7, what we have here is this scenario. So we have our quotient and our remainder. We generally don't write, though, now 6 plus 1 over 7. We just write 6 and 1/7. I've done exactly the same here with the polynomials. I've taken now the 8 and put it over now the linear factor of x plus 1. Alternatively, we could write this now as x plus 1 multiplied by that quadratic factor. That quadratic factor isn't going to factor anymore, so we have x squared plus 4x minus 10, and then we have plus the remainder of 8, and that's another way it can be expressed. It's more likely that you'll see it in this form right here. So that now is when we have a remainder. So we can say that x plus 1 isn't now a factor of this polynomial. Okay, let's do another one. Let's take another improper fraction. So let's say we've got now, let's take x to the power of 4, then we'll have, let's go for minus 4x cubed, and then plus now 16x minus, and we'll have minus 16. And we'll divide this now by, let's say, let's go for x minus 2. Okay, the first thing I'm looking at now is the missing x squared term. I've got x to the fourth, x to the third, x, and then x to the 0, or the constant. So what I'm going to do to make my work easier and not to make any errors, I'm going to introduce now 0x squared. So what we're going to have then is our divisor, which is going to be x minus 2, our dividend, which is going to be x to the fourth minus 4x cubed plus 0x squared plus 16x minus 16. So let's go through all this then. So x is into x to the fourth, we'll go x cubed times. Multiplying down, we get x to the fourth, and then we'll get minus 2x cubed. We subtract downwards 0, and then we can have minus 2x cubed. We bring down now the 0x squared. So my next question, does x go into minus 2x cubed? It does. It goes in minus 2x squared times. Or, if you like, what is minus 2x cubed divided by x? The answer is minus 2x squared. Multiplying down, we get minus 2x cubed, and then we'll have now plus 4x squared. I'm now going to subtract away 0 minus 4x squared. I now need to bring down the plus 16x, and I say to myself, x is into minus 4x squared, which will be minus 4x, and then we multiply down minus 4x squared, and then we're going to have plus now 8x. So I'm just multiplying now the minus 2 by the minus 4x. Subtracting downwards, that's going to leave me now plus 8x. We're always going to have 0 here, 0, 0, 0, and then bring down the minus 16. So just bring that down. X is into 8x, we'll go plus 8 times, and then we'll multiply down, we'll have plus 8x minus 16. So when we subtract away, we can see now that there is a remainder of 0. So we can say now that the polynomial here, x to the fourth minus 4x cubed plus 16x minus 16, is exactly divisible by the factor now of x minus 2. Or if we set this to 0, we could say that 2 was the solution. You could go ahead and look to factor now the numerator, or the quotient I should say, of this to see if we could get now either a quadratic and another linear factor or 3 linear factors. In terms of doing that, I'm going to leave it as it is. So what we can say now is that when we divide this polynomial by x minus 2, we end up with this quotient and a remainder of 0. So there we go, that's polynomial long division. Now there are alternatives to using this method. One way is to set up an identity, and we're going to look at an example of that. So let's have a see which ones we've chosen before. Now we had a look at doing this one. What I'm going to do is take this one again and use an alternative approach. What I'm going to say is the following. If we have now, and I'll write it here, x cubed, and then we're going to have now plus the 5x squared minus 6x, and then minus 2, and we're going to divide this now by x plus 1. So let's go ahead, just check that I've got that right. Minus 6x minus 2, and that is the same. Now what we can do is say the following. We can take this linear factor of x plus 1 and multiply it now by a quadratic factor. And that quadratic factor could be ax squared plus bx plus c, and then we will add to this now a remainder. Now if we're told that this is a factor, we don't need to add a remainder. But if we don't know, we just add a remainder, and we're going to say that that will be equal to a cubic. A linear multiplied, or x to the first multiplied by some quadratic, will give us a cubic. So we've got x cubed plus 5x squared minus 6x minus 2. What we do here is equate coefficients. We consider terms in x cubed, x squared, x, and then the constants. Now the way in which I'm going to do this is not always the preferred method, but hopefully it will give you some idea. So what I'm going to have now are the terms in x cubed. We could go ahead and expand this out, or we could just consider the terms now that are going to give me x cubed. So x multiplied by ax squared is going to give me ax cubed. That is the only thing that will give me a term in x cubed on the left. So we're setting up an identity, so really I should have the 3 lines here for identity. Now on the other side, we've got our term in x cubed, and we've just got 1. So that tells me now that a is going to be 1. So what we can see here is now, when I build up my quadratic factor, I already know that a is 1. So we're going to have x squared plus now bx plus c. Let's now look at terms in x squared. So if I look at terms now in x squared, I'm going to have ax squared plus bx squared. So I can simply write that this is going to be a plus b. again, you might want to spend some time thinking about this. If I multiply x by bx, I'm going to get bx squared. If I multiply 1 by ax squared, I'm going to end up with a. So let's have a look at the terms in x squared on now the right. So this is going to be equal now to 5. So at this stage, I already know from here what we've got is the following, that a is going to be equal to 1. Now at this stage, if I wanted, I can say that a plus b will be equal to 5. This is called equating coefficients. So I'm equating the coefficients on the left with those on the right. Now we already know that a is going to be 1. So we can say 1 plus b is equal to 5, which gives me now that b will be equal to 4. So we found that b is equal to 4. So straight off, I've got now x squared plus 4x plus the c. So now let's look at terms in x. So I've got x, and then now I've got x times by c, which is cx, plus 1 times by bx. So I'm going to have b plus c. They are the terms in x. And then now we've got terms in x on the right-hand side. We've got now minus 6. Therefore, what we can say is b plus c will be equal now to minus 6. Now, we already know that b is going to be 4. So we've got 4 plus c is equal now to minus 6. So c is going to be equal to minus 10. So we found now the value of c. Let's look at constants. The constants that we're going to have, or terms independent of x, we've got 1 times by c plus r. So c plus r, and that will now be equal to minus 2. So if we consider what we've got here, we know that c plus r will be equal to minus 2. We know c is minus 10. So minus 10 plus r is going to be equal to minus 2. Adding 10 to both sides, the remainder r is going to be equal to 8. So what we could do now is express this and just simply plug in these. So we're going to have now the following. We've got x plus 1 multiplied by ax squared. Well, we know that a is 1, so we're going to have x squared. Plus bx. Well, we know that b is 4. And then we've got now minus 10. And then we've got our remainder, which we've just found just here, to be 8. So this now is another way. And as stated, if we know that x plus 1 is a factor of this polynomial, then we won't have a remainder. And often when you're doing these problems, you'll simply set up the identity that you have a linear multiplied by a quadratic is a cubic, and you don't have to worry about this r. But as I didn't know, well, I did know, but I pretend I didn't know that it wasn't a factor, we set it up, we equate coefficients, and we solve. So that's what we end up with. So we're simply saying now this polynomial divided by now x plus 1 gives us now the linear multiplied by a quadratic plus a remainder. And that's an alternative approach. So let's take one now where we would be told that it was a factor. Now, if we knew that x plus 1, for example, was a linear factor of a polynomial, we could simply set up now an identity. So let's go for, let's say we got 2x cubed, then we've got minus x minus 1, and we wanted to divide this now by, let's say, x minus 1, and we were told that x minus 1 was a factor. So what we could do now is set up an identity. We've again got a linear and a cubic. A linear multiplied by some quadratic, ax squared plus bx plus c will be now equal, and here is our identity, to now the cubic. And I'm not going to add r. We could if we wanted, but we'd end up showing that r was equal to 0 if this is a factor, and that's going to be 2x cubed plus 0x squared, and then we're going to have minus x and minus 1. In this case, the 0x squared isn't important really, but it might help us work out the coefficients. So I'm not adding the r because I'm going to be told now that this is a linear factor, and we'll go from it from there. So let's go ahead and work this out. So first thing I'm going to do, a look at terms in x cubed. So on the left hand side we've got x cubed. I'm going to now get a multiplied, or ax squared multiplied by x, which is going to give me a. On now the right hand side, terms in x cubed, we're going to have 2. Now often when you're learning this, you'll be expected to multiply this out and equate coefficients. I like to jump to them. Do check with your teacher or your exam board what they expect from you. Let's now look at terms in x squared. So what we've got now over here, terms in x squared, we're going to have bx squared minus now ax squared. So this is going to be b minus a. And we can see in terms of the x squared coefficient, we're going to end up with 0. Now at this stage we could obviously do some work with this. We could see that a is going to be quite clearly equal to 2. And what we could say from here now is b minus a is equal to 0 as we're equating coefficients. Therefore now b minus 2 will be equal to 0, and we can see that b would be equal to 2. So straight off I could put now that this is 2x squared plus 2x plus c. Okay, let's look at terms in x. So if I look at terms in x, I'm going to get cx minus bx, so that's c minus b. So we get c minus b, and terms in x on the right hand side, be careful with this, this now is minus 1. So we got minus 1x. So we can see from here now, and we'll write it here, that c minus b will be equal to minus 1. So we can see that c minus now the 2, c minus 2 is equal now to the value of minus 1. So we can see that c is equal to 1. Now I've done it at this stage, but what would be easier? Well, let's just look at the constants. Our constants are minus c is going to be equal to minus 1. So straight off we can see from that c is going to be 1. Often what I like to do is take now the cubic, find a, and then now the constant, find c, and then work out b from either one of these that make it easier. So what we can now do is the following. We can write this as x minus 1. So x minus 1 multiplied by the quadratic, and we're going to have now 2x squared, that's a. And then we're going to have plus 2x, and then we're going to end up now with plus 1. So we've got now the linear multiplied by the quadratic expression, which will give us a cubic. We've got no remainder. If I'd set up r, we would have seen that r was going to be equal to 0 in this case. At this point, you go ahead and check that you can't express this quadratic as now the product of two linear factors, but as we can see, this is not going to factor. So at this stage, you've been given the choice of which method you go for. When you're doing an exam, both methods are generally acceptable. I sometimes prefer this method. I sometimes like to do polynomial long division. An example of where I'd probably like to do this one instead is if we had, let's take, for example, now let's go for 2x cubed. So I'm taking another cubic. Now, these aren't always going to be cubics, but it makes our work slightly easier to show examples using these. Let's take now minus 14x and then plus 3. And we'll divide this now, let's divide this now by 2x minus 3. Now, when I'm looking at this, I prefer now, because we've got a coefficient of 2, to take this method. You certainly don't have to, and you'll see ultimately it's not that hard using polynomial long division, but I would prefer now to look at this in the following way. So what we're going to have then is our linear factor of 2x minus 3 multiplied by some quadratic ax squared plus bx plus c plus now a constant, or a remainder. We've got our constant here plus a remainder, and that is going to be equal now to the following. We can have 2x cubed plus 5x squared minus 14x plus 3. So let's go ahead and equate coefficients. So terms in x cubed, we're going to get now 2a. So we're going to have 2a. 2x multiplied by ax squared is 2ax cubed. Okay, and that's going to be equal to, now on the right, we're going to have x cubed and we're going to have 2. Okay, let's look at terms in x squared. So what's going to give me a term now in x squared? I'm going to have 2 now bx squared and minus 3ax squared. So 2b minus 3a, that will be on the left. So all I'm doing is looking at terms in x squared. On the right, terms in x squared, I'm going to have positive 5. Okay, so at this stage, we could go ahead and just say now that 2a, we could say that 2a is equal to 2, which means that a is going to be equal to 1. At this stage, we could say now that 2b minus 3a is equal to 5. We know that a is going to be equal to 1, so 2b minus 3 is equal to 5. 2b is equal to 8, so b would be equal to 4. So I've already found now a and b. If we went for terms in x, let's look at the terms in x. We're going to have now the following. minus 3, so we've got minus 3b, and then we're going to have 2c. So we could say 2c minus 3b, and if we look at terms in x over here, we've got minus 14x. So x, and then we're going to have minus 14. Okay, so at this stage, what we could say now is the following. We could say that 2c minus 3b will be equal to minus 14. Now, we already know on here that b is going to be 4. So we could say 2c minus 12 is equal now to minus 14. 2c is equal to minus 2, so c is going to be equal to minus 1. So we've got c, we've got b, and we've got a. We can find our remainder, now r, by considering constants. So if we look at the constants, we've got r minus 3c. The constant is a term independent of x. So minus 3c, and that will be equal now to 3. So let's go ahead and look at that here. So what we've got now is the following. So let's just check that out. We've got now r, and then we've got minus 3c. Well, c is minus 1. So r minus 3c is equal to 3. So r plus 3 is equal to 3. So we can see now that our remainder, is going to be equal now to 0. So what we could do is go ahead and express this as the linear multiplied by the quadratic factor, and that will give us the cubic. So 2x minus 3, and then we're going to have ax squared. So we've got a, which is 1. We've got plus bx. b is going to be 4. And then we've got to c, which is going to be minus 1. So we can say now that when this polynomial 2x cubed plus 5x squared minus 14x plus 3 is divided by 2x minus 3, we end up with this now as the quotient and a remainder of 0. And we've seen the remainder of 0 just here. So there we go. That's now the alternative way to look at algebraic division. So you can either use polynomial long division or you can equate coefficients. There are some other methods, but generally these two are fairly straightforward once you can work through what is essentially an algorithm.